Hello everyone. Today we're going to use a simple exercise to experiment with our three different fabrication tools, including our laser, our 3D printer, and a CNC. So we're going to design a coaster, and we're going to have our initials engraved in it in the center. The circle itself has a 4-inch diameter. That's what that little symbol means. We're going to need to cut our coaster out on the laser cutter using this circle, and we're going to use text objects to create our text, and that's going to get filled by the laser. Now for the 3D printed version, we're going to have to implement a few extra steps, which will involve actually 3D modeling this coaster. We're going to take this same 4-inch diameter, we're going to extrude curve to the correct thickness that we want this coaster. We're going to use the text objects command to create the text for our initials, but we're going to output actual solid objects for these initials, and then we're going to Boolean difference the two. So we're going to subtract these solids from this solid here to create a little divot or indentation of where these initials are on this coaster for the 3D printed version. And then we'll also take a look at creating the same coaster with our initials in it, but for the CNC. So much like the laser cut version, we really only need two-dimensional lines. So laser cutting, we need two-dimensional lines. 3D printed, obviously we need a 3D model. For CNC, we really just need a series of 2D curves. Notice the letters themselves are a little bit more rounded in the CNC version, and that's because as our router bit goes and travels around these paths, it is a compact router that is spinning a 1/8 inch bit many revolutions per minute, about at least 10,000 revolutions per minute. And because it's creating that motion, that circular motion, it's creating this rounded effect. It's giving it a radius, whereas we'll be able to not have a radius in our laser cut and our 3D printed versions. But all inside corners will have that little radius. Okay, so let's get started. I've got Rhino here open, and if you didn't choose the right template yet, super easy. File, New, and these are the 10 template files that come with Rhino by default. To differentiate between which ones are here and which ones we actually want to use, let's take a look at the differences. So I've got large objects and I've got small objects. So if I'm making a coaster, I'm probably making a small object, so that eliminates 50% of these options here. If you're ever curious about what is the threshold between a small object and a large object, think of a pickup truck. If you are designing and creating something that is larger than a pickup truck, then you're going to want to use large objects, and that's really handy if you're 3D designing buildings, creating floor plans, elevations, things like that. Those are large objects, and you want to 3D model them in a 1:1 scale. Versus small objects or anything below a truck size, so small little coaster or a keychain or a small scaled model. Now within small objects, I can see different units. So here in the US, our primary unit is the imperial, so we're not going to use centimeters. We're also not using meters and millimeters, so that eliminates another half of the options. So we're left with 1, 2, 3, 4 different options. We can choose feet, feet and inches, feet, inches, feet and inches, and inches. So that first unit right there is dictating the primary units that are going to be used here in Rhino. The secondary units are going to be your display units. So I might be my primary unit might be feet, but the display will show me in feet and inches. Whereas here on this one, it's gonna, feet will be my primary unit, but it will also be the way my units are displayed. So for example, if I drew a line that was 11 foot 6 inches, in this one it would say 11 foot 6 inches, but in feet it would say 11.5 feet. So that's the difference. And same thing with inches, feet and inches, and inches. Same exact thing. Primary unit's inches, but it's going to display in feet and inches. So I'm going to choose small objects, inches. I'm making a coaster. It is smaller than a truck. I am in America. And I don't need to think about a coaster in terms of feet and inches. So let's start with small objects, inches. All right. So this is the small objects inches template. It's got the correct grid size here for me, which I can change if I'd like to. I'm showing inches down below. I'm not going to see much of the feet inch increments. So let's get started. So for the laser cut version, I'm going to draw a circle. So I can either click on this circle command, or I can type in circle and hit enter. Okay. So Rhino is currently asking me for the center of the circle. So I need to dictate where the center of the circle is. I can zoom in using my scroll wheel. And I like to start my projects right in the origin. So I can use grid snap. If I enable grid snap, if I zoom in, you will see my cursor as it moves around the grid. It is being forced to snap at the vertices, or at all of these grid points. So I'm going to put one right here. That'll be the center of my circle. And now that I've defined the circle, in my command line, it's asking me for the radius. And then in brackets, it says 1/16 of an inch. So what Rhino does is it memorizes, it can retain the information of the last time you used the command. The last time I used this command, I used a radius of 1/16 inch, which is a diameter of 1/8, which is probably, I probably had something to do with the bit, a router bit when I was CNCing. So if you don't want to use the radius, you can use the diameter. You can use the orientation, circumference, area. If you have any one of those pieces of information, you can use that instead. So let's use diameter, because I do know what the diameter is, and I could just enter 4 and then hit enter. Right? 4 units means 4 inches in Rhino, right? Because of the template that I chose, because of the primary units that I'm using, inches. So if I hit 4 and hit enter, now I've got a 4-inch circle. Okay. The next part of this for laser cutting is I'm going to use the text object command. Okay, there are 2 commands in Rhino that have to do with text, at least 2 text objects. One is called just text, so if I hit text and hit enter, it's going to show me my different text styles, the height that is going to be output. If I put my initials now, TJC, and I center align it and click OK, it's going to give me text that had those properties. So if I go to properties, it gave me text that is 0.125 inches tall, which is why it's so tiny on my 4-inch coaster. And right, that's a little too tiny. So if I were to do this again, text, I would maybe change this to, let's say, 0.75 inches, 3/4 inch. Click OK, and there we go. Now it's a little bit better, a little bit bigger. Right? If you don't like that, try it again, text. And let's say we want to do 0.5 this time. And let's say we want to change the font. We can choose from the various different fonts that we have loaded here onto our computer. Let's try, I like Franklin Gothic. Let's go heavy Franklin Gothic. Okay. Notice in the command line it says text location, right? As I move my cursor around, it's wanting me to pinpoint the location of this text. So let's just place it way off over here for a moment. Okay. Now I want to center this. So to do that, I'm going to need to move that text. So I'm going to type in move and hit enter. Command line says select objects to move. I'm going to click on the object I want to move. Now it says press enter when done. I'm going to press enter now that I'm done. And I need to dictate where I want to move it from. So I need to find a point that I want to move it from. Okay, so what I want to do is I want the center of this text. You need to have your O snap on. And you can click on O snap, and when it's bold and sort of bluish and highlighted, your O snaps will appear. Now mine are down here on the bottom left. It says end, near, point, mid, center, intersection, perpendicular, and a bunch that are off. Go ahead and highlight these same ones that I have on: end, near, point, mid, center, intersection, and perpendicular. So with these on, I can identify the center of this object by scooching in close to the edge of the boundary of this object. And now you'll see, although my cursor is way up here, it's finding the center of this object, CEN, right? And you can see sort of a small white point right in the center. If you click that, you're now going to be moving this from its center, and you're going to place it elsewhere. Okay. Now notice that as I move my cursor around, I'm not only grid snapping, but I'm also constrained to these very straight movements. I can go left and right, I can go up and down, I can go diagonal, either way. The reason for that is I have ortho on. With ortho, it is going to constrain me to these very straight up, down, left, right, diagonal movements. With ortho off, I can now move to whatever degree or radian that I want. I'm also going to turn off grid snap, so that way I stop snapping to very specific little points, right? Here's the difference between grid snap off and grid snap on, right? My center of the text is now snapping to very specific grid snaps, so I don't really necessarily need that. Also, I'm going to turn Smart Track off, and I'll explain what that is later in the semester. But what I want to do is, with grid snap on, I want to find that origin. I can also type in the origin. See, it says in the command line point to move to. I'm going to type in 0, 0, which is the origin, and hit enter. Okay. So that's one way of adding that text. Now the other text command is called text object. With text object, you'll not only create the text, but you'll have 3 different options at which to create the text with. We can output curves, we can output surfaces, and we can output solids. So let's output curves. Let's change the font back to Franklin Gothic medium or Franklin Gothic heavy. Let's go with that 0.5 inch height. We're going to do curves. We're going to group the output. We're going to hit OK. Okay. And now it's in the command line. It says pick point. Because I have the center O snap on, I'm going to hover my cursor around the edge of this circle and click once. And now that text is right there behind this other text. So I'm going to delete this text and leave behind my new text object, which is just 3 curves. Let's see how that command works in other ways. I'm going to array linear this. Let's do a text object. And let's do that same 0.5 Franklin Gothic heavy TJC as surfaces. Okay, and let's do that again as solids. Okay. So what's the difference? Here are the curves. If I click on them, they're all grouped, so these are the curves. If I click on these are 3 surfaces, right? Look at all the information our command line gives us. And then if I click on these are 3 extrusions. Okay. Here in Rhino, I'm looking at my object, or my 3 coasters, from 4 different viewports, right? This is my top viewport. This is the front viewport, which is perceiving it from the front elevation. This is perceiving it from the right elevation. And then this is just a general perspective. I could spin around. This is my 3D world view, and I can zoom in. So look at the differences. I have curves, I have surfaces, and I have extrusion. So we're going to use that to our advantage very soon. So as far as the laser cut version goes, this file is basically ready to go. Maybe I'll create a little bit extra ornament. Let's use the offset command, hit enter, and the distance that we want to offset, let's offset it 1/4 of an inch, and then let's select the curve to offset. That's going to be this one, and I can offset inwards or outwards. I'm going to offset it inwards, just like that. Okay, so as I prepare this one for laser cutting, I'm going to use layers and different colors in my layers. So here's layer 1. I'm going to call this one laser cutting. Okay, and in this layer 02, I'm going to change this one to, this will be for my text, so let's call it text. And then this one will be for my offset, so it'll be engrave. And then this one I'm going to call cut. Okay. Now I want all 3 of these layers to be sub-layers of laser cutting. So I'm going to click and drag them all into laser cutting, and now you can see I can collapse and expand this. So in the laser cutting layer, I have text, so I'm going to select my text. I'm going to right click this layer, change object layer. Okay. Now it's purple, my layer is purple, I can turn it on and off. Now this one, I'm just going to simply score into my coaster. This one's going to score and this one's going to cut. So I'm going to take this one and I'm going to change object layer. Let's call this score. That might be a better term. I don't want to cut all the way through there. I just want to nick it. And then this one is going to be cut. So I'm going to right click that, change object layer. There we go. So the laser cutting one is all set and ready to go. This is ready for laser cutting. We just need to export it as a DXF and take it over to the print station, open up Lightburn, and figure out some settings that I want to use for the laser cutter for wood. Now this one is going to be our 3D printed version. So I'm going to go ahead and delete these surface ones. I don't really need the surface ones. I'm going to take my extrusions here. I'm going to move them, and I'm going to move it from here in top view from the center of this circle to the center of this circle. Okay, and then here I can even double click perspective, so I just stay in this viewport. Let's go to our handy dandy handout. Says we want to do 0.125 thickness, so let's go ahead and take this one. We're going to use the command extrude curve. So I'm going to type in extrude curve. Okay, hit enter. I'm going to select the curves I want to extrude. I'm going to hit enter, and then the distance, extrusion distance, is going to be 0.125, and hit enter. Okay. So now I have a circle that has been extruded 0.125. I've just 3D modeled, my first coaster. And then I have these letters, which seem to also be 0.125. Okay. I'm currently in a shaded mode, but I can change back to wireframe, which allows me to see through things. I can go to ghosted. Ghosted is really nice because it's kind of the best of both worlds. If I'm not sure how tall I made that text object, I can type in the distance command, and now it wants me to find the first point of my distance. I can see this endpoint, and then I'll measure all the way up to here. That is 1/8 of an inch, which is equivalent to 0.125. So what I'm going to do is I want to subtract these 3 letters away from the coaster. Okay. So to do that, I'm going to select my 3 letters. I know they're 1/8 of an inch thick. So what I'm going to do is I'm going to move them. And you want to have the gumball on for this. This is the gumball down here. Okay, notice when I turn it on, get these red, green, blue arrows, these arcs. Okay, click on the blue arc for moving things up in the Z, positive or negative Z. Go ahead and click it once, and we're going to type in, let's type in 1/32 of an inch. Okay, it is 1/8 inch thick. I'm going to move it up 1/32 of an inch, which is barely anything. Actually, let's make it a 16th. 1/16 quotation mark. Okay, quotation mark means inches. So I'm going to hit enter, and now it's protruding halfway past my coaster. And now I'm going to use the command called Boolean difference. Okay, Boolean difference is when you take one solid object and another solid object and you subtract the two. Okay, so usually you have a bigger solid object, then you have a smaller solid object. When you put them together, they intersect, kind of like a Venn diagram. So when you do a Boolean difference, you say, I want to subtract from this big one, and I want to subtract using this little one, and it'll take that piece out of the original one. Okay, so Boolean difference, select surfaces or poly surfaces to subtract from. I want to subtract from this big coaster. Press enter to continue, enter. Select surfaces or poly surfaces to subtract with. That's going to be this stuff that's now embedded just a 1/16 inch into the coaster, but is not fully enveloped into it. So now I'm going to select that and press enter, and then look what it does. Okay, it has now subtracted those letters from the coaster. Okay, all right, so that's going to be our 3D printed version. So here in layer 5, I'm going to call this 3D print. I'm going to select this object. I'm going to right click, change object layer to move it into that layer. And now lastly, I need to create the CNC version of it. So I'm going to create the new layer, which is this little layer plus button. I'm going to type in CNC. And just like with this one here, you really just need curves, right? Even though it's CNC, it's actually not as much more advanced as the other ones. I'm noticing that now that my circles are kind of trailing downwards a little bit. I don't know what happened there, but they should have been straightened in a row. So I'm just going to simply take all of this. I'm going to move it. I'm going to move it from its center, and hopefully I still have grid snap on. Yeah, now it's going to be lined up straight, and take this guy and move him straight to this axis. All right, sorry, that was just bugging me. So one thing I wanted to make sure to cover too is in between commands, once you're done with the command, hit escape 2 times. Okay, initiate a command, go through the command, follow through. Once you're all done with the command, escape 2 times. Okay, what that does is it ensures that you're no longer actively in any command, but it also ensures that anything you had selected is now deselected. So now in my last one, I'm going to go ahead, I'm going to offset this circle, and I'm going to offset it 0.25 inches inwards, and I'm going to use the text object command. The curve, I'm going to output curves. I wonder what engraving font looks like. Let's click on engraving font. Let's click OK. All right, I'm going to find the center of my circle. Oh, okay. That's not, I don't think that's what I want. Let's hit delete. Let's do text object. Let's not do engraving font. Let's click OK. Find our center, and voila. Okay. So just like with the laser cutting one, I'm going to bring in 1, 2, 3 layers. these 3 layers I'm going to put in the CNC layer. And whenever we're fabricating, for the most part, we want to work our way inside to out. So let's say with the laser cutter, we want to do the font first. We want that to be engraved first, and then we want to do this score, and then we want to cut the whole entire thing out. Okay. If you cut the coaster out first, what's going to happen is you have a sheet of plywood in the laser cutter, you cut out that perfect circle. That circle is going to drop below the top surface of the rest of the plywood, right? Gravity is going to, nothing else is holding it, so it's going to drop down. Because it's dropping down, the distance of which the laser is to the material, the top of the material, is no longer the same. And so when you go to do your initials at the end, it will not be correct. So we want to have all of our plywood up here, do our engraving, do our circle, and then do the final cut, and then it will drop down. Same thing with the CNC. You don't want to cut the shape out first and then try to do the letters, because it'll move around. So just like I did here, I'm going to separate these into 3 layers, starting with this one. That's going to be layer 1. So for this one, we're going to call this text. Okay, change object layer if I haven't done that already. This is going to be my score. I'm going to change object layer, I'm going to score, and then this one's going to be my cut. So we'll change object layer, and then we'll also rename the layer to be cut. I can also dictate different colors. So let's say text is red, score is green, cut is blue. Okay. Notice I have distinct colors for all of these, right? Now I'm going to go ahead and, since I've done so much work and I don't want to lose it, I'm going to perform a save as. I'm going to navigate to where I want to save this. Remember, in this class, file naming and organization is very important. So under Summer 2025, ARC A170, coaster, I'm going to go ahead and call this 250616 coaster assignment test, and then my initials. Okay, save it as a Rhino file. So what I'm going to want to do now is I'm going to need to start exporting each of these into their various formats, so that way I can prepare them to use for each of their different tools. So for this one, I'm going to export. That's the command, is export. Or you can go File, Export Selected, select the objects to export. I'm going to select all of these using a big cross window, just like that, and hit Enter. All right. And for laser cutting, I want you to use AutoCAD Drawing Exchange, DXF. That is the file type I want you to use. Remember that. DXF, super important. So again, 250616 coaster. I'm going to put a dash, laser cutting, and then put my initials. Okay, this is going to be super handy to have your initials in your file name, so that way if you're sharing a computer with someone else, you'll know which file is yours versus someone else's. So DXF, named it properly, putting it in the coaster folder, and hit save. Once you get to this dialog box, just use the default export scheme and hit OK. Now for this one here, we're going to go ahead and do export. Okay, we're going to name it the same thing, 250616 coaster 3D print TJC. But the file type we're going to want is an STL, or stereolithography file. That's for 3D printing. So go ahead and click OK or save. All right, once you get to this dialog box, just click OK. And for this one, just click OK. And then lastly, we want to create a file for this one here. So I'm going to type in export. I'm going to give it the same name, 2506 coaster, and instead of 3D print, I'm going to call it CNC. Okay, and instead of an STL, once again, I'm going to want a DXF. I prefer DXF files over SVG files. So scalable vector graphics versus AutoCAD Drawing Exchange, both work, but I've learned over the years that an SVG is a scalable vector graphic, and therefore when you import your SVG into any program, it will come in various sizes. Okay, because it's just its nature, it's in its name, scalable vector graphic. That's the advantage of using something like that. It's not a rastered image. It is a scalable vector, and no matter how big and small you scale it, it will always be super crisp and clean. However, I find that using a DXF helps to retain its exact size. It doesn't accidentally scale up and down, so when I go to 3D print this, I don't end up with a teeny tiny 4mm coaster. I get a 4-inch coaster just like how I want. So that's my argument. So here's 250616 coaster CNC. I'm going to hit save for that one. Click OK for this dialog box. All right. So now we're ready to go ahead and prep this for laser, prep this for 3D printing, and prep this for CNC.